We are producing about 3,000 liters of milk per acre if I was to back our milk production into a per acre basis. And whenever we went to the high corn silage diet, by higher corn silage tonnage, dry matter per acre, we got up to about a 7,000 liter per acre average. But now that we're there, we're over 10,000 liters per acre of milk produced per year.
Overwintering is your king. Like, that is where you're going to maximize your benefits from this crop.
We had started with cereal rye, and we harvested in the springtime as a forage for our dairy cows, for the milking herd, and also for the young stock. And when we did it, we had noticed our second crops had little to no yield penalty, except we were able to produce another crop. And with the higher capital cost of land, it was a way that we could build an efficiency into our system. It kind of evolved from that. It went good over the years, and then we required less land to produce the amount of forage for the cows. So then we reincorporated wheat back into our rotation, which then we were corn, wheat, soybean rotation again, which is a little bit better for diversity on the field. That kind of led us to the fact of, after the winter wheat harvest, we still have a couple of good months of great quality sunlight we can harvest. So then we switched into a multi-species 2 years ago.
Because you're keeping a living plant in the soil, you're keeping living roots in the soil for a longer period, and you're going to have a longer window to be harvesting the sun. You're going to be completing photosynthesis all the way until the snow falls, and then once the snow goes in the spring. Having a cover crop that overwinters offers more soil health benefits, as opposed to a cover crop that gets terminated in the fall and potentially worked in the fall. You might be doing less tillage. For cover crops, we've got a couple different life cycle options. We've got fall terminated and overwintering cover crops. So differences here, a fall terminated is going to be killed in the fall or by the snow, by the winter, by the cold. An overwintering cover crop is going to be able to survive the winter and then continue its growth in the spring. Depending on your operation, you may be incorporating or leaving that residue on the soil surface, which can impact when you might want to terminate your cover crop. So when it comes to terminating cover crops, there's a couple main options. One, there's mechanical, which would be tillage, and then there's chemical. So oftentimes a burn down with something like glyphosate. A lot of the times people might also, in the spring, livestock growers might be feeding that cover crop, so they're going to be terminating it by harvesting. A couple different options, and it's very operation specific. I don't recommend blanket approaches for cover crops. I recommend tailoring everything to your operation to make sure that it fits and that it's a practice that you're going to want to continue to use because you've tailored it specifically to your uses.
The advantage came from whenever we started double cropping was we learned how to use the sun in the beginning of April, or as soon as the plants would green up and start growing, we were actively harvesting the sun. So I think the goal, like I said, is as we go to a biological approach, one of the goals is also to learn how to harvest the sun better, because the sun is the driver of the growth. So our goal was to get 4 different plant families. Usually in the soil, some good things can start happening when you can incorporate at least 4 different plant families. We incorporated 2 species from 4 different families. We had sorghum, rye, wheat, triticale, clover, buckwheat, radish, vetch, and sunflowers. The first year we didn't have the triticale, but the clover didn't overwinter much, so we kind of cut that back and added triticale this past year. So far I've liked what I've seen, but we have to see how it comes out of the winter. We are producing about 3,000 liters of milk per acre if I was to back our milk production into a per acre basis. And whenever we went to the high corn silage diet, by higher corn silage tonnage, dry matter per acre, we got up to about a 7,000 liter per acre average. And how I calculated the number with the double cropping, because our soybean yields are always just as good or better with double crops. Corn, you might have a slight yield penalty. So I didn't count the soybean acres in my calculation because we were still growing a full soybean crop after that, even though we're using the field early in the year for forage. But now that we're there, we're over 10,000 liters per acre of milk produced per year. From a land use efficiency, it has really brought great efficiency to our farm. I think the outcome so far has been beneficial. I think it's helped our irrigation a bit more in the soil. The radishes really help break that soil up, get some holes built in the soil. If you look at like erosion reduction, we had a pretty cold, blowy winter with lots of snow. And the snow here, as it melts off the rest of the way, is still very clean. So reduction of erosion, it's always a win. It makes a pretty good forage. Last year was 70% protein with, I think it was like high 60s digestibility. It was actually almost too powerful for feed. We slowed it down a bit with straw. It's good for the pollinators because buckwheat comes first, and then it was almost one pollinating from about the end of August all the way till it dies in frost, because there's always a new one that flowers.
Doug mentioned looking at different families. Different cover crops have different functions. So the grasses, they've got a lovely fibrous root system that's great for breaking up soil and creating channels in a smaller capacity. And then we've got tap-rooted crops that can be anywhere from a sunflower taproot, which is fairly small, all the way to your daikon radish, which creates those giant holes in the soil. And when those die off, they leave big holes in the spring that leads to better water infiltration. But they also provide a lovely, nutritious, sugary goo when they break down. We're feeding microbes. Anytime a plant is growing in the soil, the root exudates, so it puts sugars out from the roots, and those feed the microbes. So that happens with all species. Another benefit will be your legumes. They fix nitrogen. They have symbiosis with nitrogen-fixing bacteria. So you're able to sequester nitrogen, not just carbon, from the atmosphere and put that into the soil. So there's other species that have more niche purposes, like the brassicas, particularly your mustards, that can be used for things like pest control and biofumigation. So there's a multitude of environmental and agronomic reasons to be using these, even if they're not overwintering. But specifically for an overwintering cover crop, we're going to be focused on erosion. So having those roots in the ground for that extended period of time into the spring, you're keeping that soil in place. You've got cover on the top from the plants that's reducing wind and water erosion as well. And then those roots that are really holding that, they're also able to scavenge nutrients that may be left behind from the previous crop. So you're trying to waste less fertilizer possibly. Another benefit of not just overwintering cover crops, but having that residue there, we can see that it traps snow. And what that does, if we're trapping snow in the field, that's water for next year that's going to be able to be available to the crop. We are working with increasingly drier soils, so whatever water we can capture is beneficial.
This is a way that I can manage labor very efficiently and increase diversity. And what I mean by that is with the rye overwintering and the wheat and the vetch and the clover, I still will put it all into the same bunk, but with having 4 different plants in that bunk, I have a reductionist time approach because it doesn't take me long to feed, but I have a biodiversity increase because I'm feeding more than one thing. 2 years ago when I started multi-species, I only planted 40 pounds per acre of rye seed, and I feel like the stand was a bit thin in the spring of 2025. So in the summer of 2025, I upped it back to 80 pounds per acre of rye with the same 15 pounds per acre of the cover crop blend. And so far, I've been happy with how it looks coming through the winter. It's too early to tell yet because we haven't started growing yet in the 2026 season, but that was a challenge. I think it always takes adjusting. If you have enough acres and even if yield is down a bit, it's okay because you'll work through it. Obviously, the goal is to produce enough forage for the cows.
Some main challenges would be getting on that field in time to be able to plant the cover crop. Cost perhaps might be a challenge as well. Depending on what species you're using, it might be something that you're not interested in. I would say cost is probably the biggest barrier for people adopting cover crops, particularly if they are strictly cash cropping. In a livestock system, they're able to feed that and get the return from that. In an organic system, it's important to have cover crops and incorporate them because you're using that as green manure. They don't have access to the synthetic fertilizers. But if you're cash cropping in a conventional system, the incentive isn't there when we're talking about the livestock and organic. So seeing the return on investment is difficult, partially because we're dealing with more abstract variables. We're dealing with results that aren't measured as often. They're difficult to measure, or they're expensive to measure. So we're talking about all these soil health improvements. Like, yes, people can soil test every 3 years for the nutrients and the organic matter. We want to move the bar on that organic matter, absolutely. But if you're looking at the microbial activity in your soil, the microbiome, those tests can be fairly expensive, and you would need to do them repeatedly. So it's hard to measure the benefits of a cover crop to translate that to dollars, which is something is the main barrier, I would say, to adoption, which is why it's great that programs like OFCAF are available to help reduce that barrier. Weather is definitely a big challenge sometimes. Last year, it was really dry. People seeded their cover crops and they didn't get enough moisture for about a month. So the seed sat in the ground for a month. Some of it would have lost viability, some of it would have died. And then it waited until the rain before it was able to germinate. So you're losing, a good time out of that soil health benefits. That's a month pretty much that your soil is sitting there unprotected and that you're not seeing that cover crop come up. So that's one thing that might prevent someone from adopting cover crops, is the uncertainty of success. When it comes to red clover, all of that gets frost seeded into wheat. That is probably the biggest one with uncertainty, because it's difficult to get a consistent and uniform catch across the field, especially with the seeding method that's most usually used, which is an ATV with a spinner on the back. Again, the consistency of establishment is definitely another barrier. So one way to overcome inconsistency in your cover crop establishment would be to change your seeding equipment or change the rate at which you're going. So if you're seeding red clover behind an ATV, make sure you're going the same speed throughout the field, so you're theoretically dropping the same amount of seed, instead of going one speed and then it starts to get cold and you want to get out of that field. So you pick that speed up and the rest of that field gets a quarter of the seeding rate. Soil moisture, again, an environmental factor we can't control so much, so we try to get seed into the soil. A lot of cover crop seed gets broadcast and incorporated, but for the best chance of success, it would be drilled into the ground. But that is more expensive. So again, we're talking about trade-offs. Broadcast and incorporated, cheaper, quicker, lower chance of success.
Don't be afraid to try. I think these are all different things that was pretty new at the time. It takes a bit to start. The first time is always the hardest. If you do try to do it, just try to get some time to go and observe also what you see in the field. Nature always wins. The more you work with nature, the more things should go in your favor. And nature naturally would produce biodiversity. So not that I'm against monocrop, but it's just working more with nature. So as you work more with nature, if we can increase it's more so looking at the soil through a biological lens, more so than a chemistry lens. That's kind of the main shift. By doing so, you're less susceptible to leaching, to erosion, to to the environmental factors that we have to deal with. Nature, if you can get the biodiversity right in your soil, it can feed the plant better than we can. Like it's the right place, like the 4 R's, the biodiversity will always do that better than we can do it. So it's just the goal of trying to let nature manage some of the field aspects by itself.
As Doug said, we do want to try to farm with nature, which means nature doesn't have bare soil unless you're in the desert. So we want to make sure we're covering that soil, providing some food for the microbes, reducing erosion, increasing organic matter, improving soil structure and aggregation. All these things are going to help the main crop down the road, because a healthy soil with a healthy microbiology is going to be able to provide more for the crop as opposed to a dead, sterile soil.